Hello guys, I am here to explain lower bound and upper bound widely used in competitive programming. Let's discuss how these functions work actually. These are two functions given by C++ STL and are really essential for speedy binary search in any array, right? For working of lower bound and upper bound, the array should be non-decreasing usually, but it can be non-increasing also, right? So let's begin. Let's first discuss what is lower bound. Okay. What lower bound does is it returns us an iterator pointing towards an element which is greater than or equal to the current element, right? For example, let's say a vector int v is 1 2 6 7 8 11 12. Okay, this is our vector and we want to find 7. Okay, so and if I print out lower bound value at lower bound, v dot begin, v dot end, and 8. Okay, this will give me 8 because 8 is found. Let's see, let's run this. Yep, 8 has been found. But if I try to find 5 here, okay, 5 cannot be found here because there is no element which is 5. So the iterator will be pointing at 6 and the value at that iterator will be 6. Let's check. Yep, it got me 6, right? If I am finding 10, this function will give me 11 because 10 is not found here, so it will go towards the iterator which is greater than or equal to this element, right? 10, immediate greater than or equal to 10, it is 11, right? What if the element is not even in the vector at all? Like if I am finding 21, if I'm finding 20 here, right? 20 is not in this vector, so the iterator will become v dot end, right? Let me get an arrow. The iterator will not be pointing at either of these values, but it will point at somewhere here outside the vector, and the iterator will be v dot end. Okay, this is v dot begin, this is v dot begin plus 1, this is v dot begin plus 2, and here this is v dot end. Okay, this is how it goes. So it will be v dot end, right? So let's first check if our given iterator is outside the vector or not, right? If okay, first let's define an iterator, initialize an iterator. Lower bound. Okay, this is the iterator pointing at trying to find 20. If iterator is equal to v dot end, that means if 20 is nowhere in the vector, then cout not found because all the elements are smaller than current than 20. Okay, but if it is not v dot end, like it is pointing at any of these elements, else we'll just simply print out the value inside that iterator. Okay, cout value at it. Yep, it's done. Let's try to find 20 here. It gave me this. Let's try to find 12. Okay, it should find 12. because 12 is the last element of this vector. Yep, we found 12 here. Okay, element found 12. If I'm trying to find 10, it will give me the iterator pointing at 11. If I'm trying to find 0, if I'm trying to find minus 100, right, minus 100 is also nowhere in this vector, but we can find an element which is greater than 100, minus 100, which is the very first element, 1. Let's try to run. The iterator will be pointing at 1. This is how lower bound works. Okay, now what is the significance of greater than or equal to in lower bound? Okay, that we need to discuss. That is there because what if the vector is like this, 2, 3. Okay, what if the vector is like this and I want to find the iterator of this 2? Okay, 2 is also here, 2 is also here, 2 is also at the end here, but I want to find the very first iterator here. So in that case we can use lower bound function. Okay, let's try to run this and find 2. Okay, let's try to find 2. Yep, we got 2, but I want to now print the iterator, like what is the index for the very first occurrence of 2, right? For that I can just simply do is it minus v dot begin. Simple. If it is here, right, and it minus, and I am executing it minus v dot begin, so what it will do is v dot begin is the very first element and it is here, so it will just minus and it minus v dot begin and we'll get the index. Let's run. Element found 2 and the index for it is 1. If I am finding 8 here, okay, for 8 it will give me the index for 12. Index for 12 is 10 and the element is 12 itself. If I am trying to find 28, 28 and it's not there, the index will be size of this vector. Okay, index will be size of this vector. Let's put this out of this if else ladder and just run, because we have to print index anyways. Index is 13, right? The size of v is also 13. 1 2 3 4 5 6 7 8 9 10 11 12 13. This is how low bound is work. But what if I want to find the index for the last occurrence of 2? What can I do in that case, right? In that case I can either use lower bound and just find 2 plus 1. In that case it will give me 3 or any element greater than 2 and then just minus the iterator, or I can use upper bound, which I'm going to discuss now. Okay, let's just put it here only. Now what upper bound does? Upper bound does is it returns an iterator pointing towards an element strictly greater than the passed element. Like if I am finding 6, okay, so it will give me the iterator pointing at 12, not 6. That's the characteristic for upper bound. Okay, let's run this. Okay, see, it gave me the element 12 and the index 10. If I am finding like say 8, still it will give me 12. Okay, please drop down any questions you might have with this code. I will be more than happy to answer all of you. Okay, now what is the significance of returning the iterator for strictly greater than an element, right? Because if I am finding 2, okay, if I am trying to find 2 and let's run, it gives me the index for 3. It gives me the index for 3. Now I can just minus this index and get the last element, right? That's how upper bound is used. Now what I can also do using lower bound and upper bound is I can find number of occurrence for 2 in logarithmic time. Okay, let's do that. It left, it is lower bound comma 2. Okay, it will point here. Now for upper bound, um, upper bound will, this is our lower bound, right? Lower bound iterator. For upper bound it will be here, upper bound. Now now taking the absolute difference between these two iterators, I can find the total number of occurrences for 2. It right minus it left. Let's run this code now. Total number of occurrences for 2 is 7. 1 2 3 4 5 6 7. This is how upper bound and lower bound can be used. Now what if number of 2's were till the end? Upper bound will be at pointing at the end of the vector, and lower bound will still be pointing at the beginning occurrence of 2. Let's run. Still the answer is correct, 7. What if there were no occurrence of 2? Right. Now both the iterators will be pointing in the end, because for lower bound also there is no occurrence for 2. Same case for upper bound. So the answer will be 0. Yep. This is how lower bound and upper bound basically work. Please drop down any questions or query or any additional thought you might have in the comment section, and I'll be more than happy to read your comments. And thank you. That's all, and see you with the next one. Bye.